already thinking about the group project. Maybe some of you started doing a bit of a literature review or something like that. So yeah, it's really good to see people interested and engaged. And yeah, hopefully this intro session that we're going to do, we're just going to have a bit of a discussion about what's in the project spec. Hopefully this intro session is a good use of time for you guys. You get a bit of information, a bit of ideas on how to start working on it. And yeah, hopefully this is good. As before, this is optional, so there's no marked attendance or anything. And as with the lab sessions as well, we've set up chat rooms and help rooms. So hopefully the slides will only take 20 or so minutes to talk through, and either during that time or especially after we finish the slides, Andrew and I will hop into a help room each, and you guys are welcome to join as an individual or with the rest of your group. And maybe you got some questions about the group project or even the lab that's still open. So yeah, any questions are welcome, but let me share my screen now and get these slides going. Screen. Okay. All right, I think you guys can see that. That's good. Okay, so as we said, talking about the group project today, I guess the first thing we can mention is the objectives. So, there's, I guess, three main things that we're going to be working on in this group project. The first of which is technical, and the last two of which are sort of like deliverables to demonstrate the work that you've done. So summarized nicely in one sentence, what we want to see you guys doing in this project is to develop your own methods for cell segmentation, tracking, and analysis. And when we say analysis, there's a few things in there, but most importantly, it's identifying cells that are in the process of dividing. Okay, Anthony has a question. Maybe I'll let Andrew answer that in the chat. But yeah, so there's sort of three things we want to do when we're looking at these microscopy sequences of cells. We want to segment them, we want to track them through frames, and then we want to do a little bit of analysis and importantly identify the cells that are in the process of dividing. And now here, and this is taken from the words that are written in the spec, it might be a little bit confusing when we're saying develop your own methods. We don't mean that you have to come up with some completely new technique that's never been tried before and you're coming up with your own theory. Obviously, that's a very tall order. We wouldn't ask you guys to do that. When we say your own methods, we mean your own implementation, but it can very much, of course, be existing methods that you found from your literature review or from any other sort of online research. So, you don't have to be inventing the theory yourself. You can have a look at the lecture slides and different sources out there, but importantly, you're implementing and coding these methods yourself, and those methods are going to be doing segmentation, tracking, and different analysis. So once we've done that technical work, there's no marks in the marking criteria for how well your work performs. There's no marks for like accuracy or recall or something like that. There are marks for deliverables, and there's two of them. The first is a video presentation / demo, and in there a bit of a live Q&A, and we'll have a slide in this presentation to talk about that. And the second of those is a written report explaining your methods, the experimentation that you did, showing some of your results, things like that. I guess one thing to notice is that these two deliverables, the presentation and the report, are very correlated. It's almost as if the report is sort of a longer form version of the stuff that's going in your presentation. In your presentation, it's more about sort of visual, brief, using diagrams to sort of explain the techniques and your results. Okay. So I guess the first thing we can do is to have a look at the data set. So as we said, the data set is microscopy sequences. Precisely, we've got 4 different sequences, each of which is comprised of 91 frames. And out of all of those frames, they roughly look something like this, and they're given to us as images in the TIFF file format. Meaning that each pixel has 16 bits of information in it, and that encodes a color value somewhere in that color spectrum. So even though this might look like a grayscale image to us when we open it, keep in mind that the information in each pixel does actually encode a color. So if we wanted to treat these images as grayscale, we might need to do a bit of conversion there. Obviously here we can see the cells can be a bit hard to see. So, of course, something that might spring to mind is maybe we could do some pre-processing, stretch this out, make the cells more visible to us, and therefore, hopefully more visible to any sort of segmentation methods that we want to apply. But yeah, that's what we've got. We've got 4 sequences, each of which having frames spread out through time, showing cell movements, and this is approximately what they look like. Here's an example, I think, from the first sequence. Okay, So some of the methods you guys might want to use for either segmentation or tracking or both might be supervised methods, meaning you're going to need some sort of ground truth data to give to these methods in order for them to train and learn the task. So provided, I think, with the first two of the 4 sequences, we do have ground truth data, not for every single frame in those sequences, just for a select few. So it is limited. And of course, if the ground truth data that's there isn't enough, you're more than welcome to enhance it and add your own ground truth data. But for segmentation, this is what the segmentation labels look like after you apply a bit of contrast stretching. If you go into the data set that you can download from WebCMS now, you'll probably find you'll open these labels and you see absolutely nothing, just a completely black background. It's because the labels aren't really meant for us to look at. They're really encoding the precise position and borders of cells as far as training a method, meaning we should see a uniform pixel color value in these TIFF images for the background and unique color values representing the position and size of each of the different cells in each frame. So what we'll see here after we've contrast stretched it, the background is looking like it's got an intensity value of 0 in the 0 to 255 range, in the range that we're familiar with. And because we've stretched it, each of these cells that have been segmented properly should have a constant intensity value. So that intensity value represents all the pixels that belong to that unique cell. We'll see the intensity values across this image should be unique for each cell. So before all the contrast stretching, it does look like this, just not in a way that we can see it. But if you reshape this data and use it properly, this can definitely be used as the true values to train a supervised method to run that segmentation. Not saying that you have to use deep learning. That's just an option for you guys. It's very open as far as the techniques that you're allowed to use. We see a similar thing for tracking. We have, a similar amount of ground truth data for tracking. Here's an example, I think, taken from the second sequence. We'll see, obviously here we've applied the sort of range fitting and contrast stretching here as well to sort of make it visible to us, because again, that's just a black image as far as the eye can tell. If we were to just go and open that straight away, what we'll see, I guess what's important between the tracking and the segmentation is the tracking isn't really concerned with the entire size of the cell. Really what we're tracking is the centroid, so the middle position of that cell. And what's important in the tracking data is that from one frame to the next, the same cell is going to have the same intensity value, aka label, in each frame. So we can get a consistent ID for that cell through the frames, therefore identifying it so we can track it. So that's something special about the tracking data compared to the segmentation. So the segmentation data is concerned with the shape, the actual volume of that cell. The tracking data is really just concerned with the centroid position and importantly, consistency between frames. Okay. I guess we can talk about the tasks. So there's 2 primary technical tasks making up this project. The first one is to segment and track the cells. I'd say that's the majority of the work here. That represents the biggest part of it. We'll see task 2 sort of follows on from this. So for each of the 4 image sequences in the data set that's given to us, we want to segment the cells, and we want to show that segmentation by drawing their contours, aka their border, in those images in some unique color. So around each of the cells, we want a unique color per cell. We want a border, very thin border drawn around that shell to show that our segmentation is picking up the actual contour of that cell. And obviously, there might be some imperfections because some cells might be harder to see or overlapping. So it won't always be perfect, but we do want to see eventually, once you're getting your output here, the outline drawn around each of the cells in the image. Now, once we have our segmentation working and giving us an output that looks like that, step 2, I suppose, is to track the cells over successive frames in each sequence. And when we track the cells, we want to show that information as like a trajectory. So when we say trajectory, we imagine over each frame, we mark where the centroid position of that cell was. That's going to give us a sequence of points in our image space. And we want to simply just draw like a straight line between each of those points. And that's going to give us what we'll call a piecewise linear curve, showing roughly the movement that that cell has taken in that sequence up until that point, right? So we should see these lines getting longer as we step through the frames towards the end of the sequence. Importantly, we want to make sure, the segmentation, obviously, the segmentation needs to be accurate in order for us to get accurate tracking results. And we want to show the accuracy of our tracking by making sure that we're using the same color as the segmentation contour when we're showing that piecewise linear path for each of our cells. We should see that consistent color, and we should be able to identify and track that cell through all of the frames. Importantly, if a cell divides, obviously that cell sort of goes away and splits into two daughter cells. Each of those should get a new color. So it's almost as if they've just entered the frame, they've just entered the sequence, and then from that frame on, we can track them through and start drawing their trajectories as well. Okay, so once we have that written up, we want to be overlaying all of that visual information on top of our image frames. And we can imagine if we then played our image sequence of frames like an animation, so, playing one frame every, some 10th of a second or something like that, we should see cells moving with their contours following them, and that tracking marking the positions, drawing out a line as we play this sequence. Here's just a visual example. This one's probably a bit more precise than what we're expecting. The contours there, are very accurate and very detailed, and the tracking lines probably has a lot more frames included here. But roughly, this is visually what we want to be seeing. So each of these cells has a unique color chosen out of some pool of colors. We have the outline drawn. That's in each frame showing the contour, and then their previous position shown as this set of lines joined at centroid points, showing their movement through previous frames. If we were to play this animation, we see the cells move around and these lines draw out following their position. I guess an important thing to note is that there's absolutely no restrictions, as far as I can tell, on techniques in this assignment. So, segmentation or tracking or whatever, if you can use handcrafted features, you can come up with a way to do it without any sort of deep learning. That's fantastic. That's more of like a traditional computer vision approach. You're more than welcome to use that. Otherwise, maybe your group is more experienced in deep learning, and that's the background that you have. Then you might want to look into supervised approaches for training a neural network to run this segmentation or this tracking. Of course, there's other approaches, under the umbrella of unsupervised learning, maybe some sort of reinforcement learning, something like that. So really the whole, scope of artificial intelligence approaches are open to you. And, any sort of technique that works and does the job is going to be satisfactory. What's most important is that you're implementing the techniques yourself and you're able to communicate that you really understand how they work on a technical level. We don't want you just copy pasting code, not really getting an idea of how the technique actually works. We want you to show us through the demonstration, the video, and the written report that you understand the techniques that you're using. That's more important than getting perfect results, is showing a solid understanding of what's going on. Okay, so task one, as we said, segmentation, tracking, and identifying cell splitting. Task two really follows on from that. If you get your segmentation and your tracking working, a lot of this should be pretty simple algorithms to run, given task one as input. So for each image in each sequence, we want to show the number of cells that are in the image. And if we have our segmentation working, that should be very easy. We want to approximate the average size of the cells, not in any sort of real measurement, just in pixels. Importantly, we just want to ignore boundary cells, but once you know the positions of the cells and all the pixels that make up each cell, it should be very easy to determine which lie on the boundary and which don't, in order to know whether to include them or not include them in your calculations for average size. So that should be a simple thing. Once you've got your segmentation, part three relies on having accurate tracking. So we want to see the average displacement of the cells, or importantly, their centroid positions from the previous frame to the current frame. And obviously that's going to be in pixels, approximately. So from the previous frame to the current frame, on average, how far did each cell move in pixels? And then step four, we want to see the number of cells that are currently dividing in that frame. And that's the only part of this second task that we want to have a visual output for. The first three, we just want a written output either to the console or overlaid as text in a corner of the image. But the number of cells that are currently dividing, we also want to show that visually, for example, like a big red box around a cell that's in the process of dividing. So we're seeing its contour and its path up until that point, but also a box saying, identifying very clearly visually, yeah, this cell is dividing. So, a lot of this stuff just derives from having accurate, results from task one for the segmentation and tracking. Okay. I guess then we can talk about the deliverables. We said they're very correlated together, but we'll look at these separately, and we should see they're mostly comprised of the same stuff. The first deliverable, as far as when it's due is concerned, is the demo. So this is a video presentation, and it can be up to 10 minutes long, just showing all of the work that you've done on the project. So the majority of that 10 minutes should be taken up by a PowerPoint slideshow presentation. And on top of that, a voiceover and whoever's speaking having their webcam overlaid so we can see your face. We want a presentation and we want it to introduce the problem. So, that means introduce what the tasks are. We want to do segmentation, tracking, etc., and talk about the data set a little bit. That's an important part of the problem. We want you to explain the methods that you use, so in real technical detail, and for a presentation using a lot of diagrams and visual examples, explaining how that method really works, and if you think it's necessary, a bit of details about how you implemented it yourself. Then we want you to show and discuss the results that you obtained. So as part of that, when we're saying results here, these are the results of some sort of experiment or experimentation. So we want to see you saying, well, here's our experiment. These are the variables. These are the metrics we set up to measure the success of different approaches maybe that we tried. And then when we say results, we want scores like accuracy, precision, recall, etc., for the ones where that's relevant, and also visual results showing examples of where your approach has performed well. The segmentation was really good. Maybe some examples of where it didn't perform well, because you can use that as a talking point, sort of have a discussion. And that's, we don't just want to show you results, we want to discuss them. Why don't we think it did well? Why did it do well in some cases? Things like that. And then the last part of that slideshow should be very briefly suggesting some ideas, just on the surface level, really. Ideas for future improvements. So maybe if you have more time to work on it, and from working on it, we learned X, Y, Z, and with that in hindsight, maybe we try these other techniques, or maybe we want to refine this a little bit more, give this more time to run, more training data for this, things like that. As I said, that should take up the majority of your presentation time. So out of that 10 minutes, as a rough guide, maybe 8 or 9 of those minutes are taken up by the presentation. That's where the meat of it is. And then the remainder of your time there should be taken up by like a recorded demonstration of your methods in action. So what that means is we want to see you show, well, we're going to show the methods working on, sequence 1. Here's what sequence 1 is. Here's the images. Now we're going to run our code. We see it processing. And importantly, we're showing the output. And really, this is all these tasks are tied together, right? We're segmenting. We use that to do the tracking. We use all that information to overlay things about the number of cells and the size. That should all be able to be shown in one sequence output. So we want to see input, processing, and output, demonstrating that it really works. Here's what the results look like. Maybe it's a success, maybe it isn't, so on. But we really want a demonstration of it actually working on top of explaining it in your presentation. For the presentation, I guess an important thing to keep in mind is that all group members must present at least a little part of the presentation or the demo, meaning, if you have 5 group members, each group member should have, at least like a 30-second sort of chunk where they're saying something. They've got a slide they're talking about, they're doing their voiceover, and their webcam is, a video of their faces overlaid on the screen. Maybe not through a webcam, you can do that through your phone if you want something like that. But we want it, really the video of your face is there to verify that it is that group member that's talking and they did contribute. Okay, and then you're submitting that as a pre-recorded video file, 10 minutes long. But what we're going to do is we're going to have sessions during the lecture slots, I think in week 10 or something like that. And everyone's going to be present. All of your group members need to be there, and your tutor and the lecturer will be there. And we'll watch your video live, and the tutor and lecturer will be marking it and writing down comments. And once it's finished playing, there'll be about 5 minutes or so for a quick Q&A. So the lecturer will ask some technical questions. How did you implement this? What would you change about this? Things like that. And all of your group members should be there, and someone can be answering those questions. Okay. The second deliverable is the report. This is taken directly from the spec. I think the spec did a really good job of explaining what needs to be in the report. You'll notice it's really just a more detailed version of what's in the presentation. So it's a 10-page report. That's quite long, but as you can see, there's a lot of stuff we want to fit into it. It's in that 2-column IEEE format, and there's a link there as shown in the spec that'll take you to a page where you can get like a LaTeX style file or maybe a Word template document to help you set that up. You're also submitting your source code, but all of the marks here are going to be for what's in your report. So there's an introduction, as we said, that's talking about the task and the data set. We've got a literature review. So for all the techniques that you use, you've obviously sourced that by reading some kind of article or some kind of, tutorial or something like that. We want a literature review where you're saying, well, we read this article by this author. Here's the technique they used. Here's a bit of context about where they used it. And, this was good, this was bad. So you're doing a very brief, sort of succinct review of that article. And we want to see that for each of the major techniques that you're using in your project. After we do a literature review, naturally, we're going to talk about the methods. So we want you guys to really explain in technical detail how those methods work to really convince us that you didn't just copy paste some source code. You got a good, solid understanding of how the techniques work under the hood. If needed, a bit of implementation detail, and obviously referencing back to your literature review. And we should see a lot of visual stuff in there, like diagrams, graphs, equations, things like that. And then after you explain your methods, that flows nicely into talking about the experiment. So we're not just saying methods straight to here's the results. We need some experimentation in there. So experimental setup means here's what I'm experimenting with. Maybe we've got one tracking method, but we're going to try these two or three different segmentation methods, and we're going to experiment on those and try and figure out which is the best. And in order to make that determination, here are the different quantitative and qualitative metrics we're going to use. We're going to say we're going to measure accuracy, precision, and recall. Here's what they are, and here's why we think they're a good measurement for this experiment. And then we want to show your results. So scores against those metrics, and importantly, some visual examples, just like in the presentation, where your approach performed well or where it performed poorly, and use that as a discussion point. And then, that as we see here in part 5, that flows nicely into discussion. So our method did well here, our method did bad here. Maybe we missed out on this, or we think we really innovated in this area. Good and bad, as long as it makes for a nice, interesting discussion about the methods and the results that you got. And then a conclusion where really you're doing a brief summary of your results and discussion. And importantly, this worked, this didn't work. And just like in the presentation, what will we change in the future? What other avenues might we want to look at? Okay, we're going to follow that up with references. I don't know exactly if there's any marks references. We'll have a look. But, you should have references for obviously everything that's in your literature review. There might be some other things that you're referencing when you're talking about methods and maybe the experimentation, like the metrics that you're using and things like that. And finally, there will be a small amount of marks for contribution of group members. So that'll be just a very small thing right at the end of your report, where each group member just writes like a dot point, a few sentences about what they did. I worked on implementing segmentation method A, and that's what this was. And then I also helped produce the presentation, and maybe I recorded XYZ in the demo, right? Things like that. Okay, this is the marking criteria that was also taken right from the spec. The important thing, if you're going to take one thing away from this whole intro session, the most important thing to notice here is there's not a single mark that says, cell segmentation or cell tracking has to be X accurate. You have to get this precision score or this recall score. There's nothing like that. There are absolutely no marks here that stipulate that your approach needs to be a certain level of successful, right? You'll see all of the marks here about putting together a good demo, ticking all the boxes in here that we were seeing, really making sure that you're explaining your methods well, you're showing your results, your demo is nice and smooth. We're clearly seeing, something's working. In your report, you've got a literature review, you're talking about everything, your experiment set up well. All of these things are going to be what fills out these marks for you when we're adding up to the 40 in total that this is worth. There's not a single mark here that says your approach has to be this good. So my main piece of advice is, obviously in this early stage of the project, it's really good to focus on experimenting and trying different techniques and trying to get everything working as best as you can. But as we get towards the end of this project, we get towards weeks 9 and 10, we really want to make sure that a lot of our time is focused on putting together a good demo and a good report, because that's where our time is best spent to maximize these marks. And that's what's going to help us do well in this project. So make sure when you're working on things, I would always suggest while you're working on your techniques, you should of course be, putting things in your literature review while you're out there discovering and learning about different techniques. Maybe put some slides together for your demo as you go, so you're not all leaving it to the end. And just make sure you're always checking against this marking criteria to make sure that there's not something, huge that you're missing. We want to always be ticking all of these boxes here. Okay. And then this is the last slide.
Marking criteria.
Yep.
There's no explicit thing there's no explicit mark for references, but that kind of just comes under, I guess, presentation quality, plus also so that you don't get flagged for plagiarism because you used an idea from some other paper.
Yeah, that's true. So if anything, that might be worth all of the marks, because if you don't do references, you could get flagged and get a 0. So that's a really good point. Don't leave the references till the very end. We want to see, all the claims that you're making in the report be referenced. Any technique you got, maybe you saw a bit of source code here and there, make sure you're referencing that too. That's a really good point. And if you don't have references, that obviously detracts from the overall quality of what you're doing. So you could lose some marks there too. This is always something we can go back and check as we're going and make sure that we're ticking all these boxes. Yes, yeah, Anthony. Just as last time, yeah, I'll email those. Email these slides out right after the session. Cool. So yeah, as we said, now's a good time to get started. Maybe some of you already had a bit of a start, but if you're stuck and you're not really sure what you can do, because this is quite a big project, you're working with a lot of people, maybe you haven't worked with before, it can feel a little bit daunting. It sort of feels like where do I start? There's all these different things I could try. These are just a few pieces of advice that we would have for you. We think you should start with like a literature review. Naturally, when you're running your report, that sits right at the beginning after your introduction, your literature review. And if you don't already have some ideas about what techniques you use, that's the best thing you can do to learn about what techniques are successful. So the project spec already has, I think, almost a dozen references in there that are going to help you start to learn about the different techniques that are out there. And honestly, those might be all that you need in order to say, well, okay, now I learned about this technique, I know how it works. Let's try and implement that and see how it goes. So start with the references in the project spec. They're all very relevant to this project. One thing is especially if you're like an undergrad student and you haven't really done this sort of thing before. I know when I took this course, I hadn't really done reading articles and putting a literature review together before. So these articles are going to be hosted on a publisher's website. A lot of the time you'd have to pay to download it. However, you're a university student, and that means you can sort of authorize yourself with that publisher through UNSW. So if you go to the UNSW library website, there's a databases section that lists out all the different sources where you can find articles and essentially, if you're viewing an article, maybe the first one in the spec, I think written by Eric himself, you hop on and view the article. It's hosted on the IEEE website. If you go to the UNSW library website and you type in the IEEE, there'll be a link there. You click that, it'll basically authorize you with IEEE. If you search for that article, you'll be able to download it. So you won't have to pay. So please don't pay for any articles or anything like that. Your university email should give you access to everything that you need. And if you got any questions about that, the help chat will be a good place. So we can point you in the right direction if you're not too sure. I would suggest as well, as early as possible to host a meeting with all your group members, because some people might have ideas, some people won't, but the discussion that will come out of having a meeting, on Teams or Zoom or whatever that works for you guys, will be really beneficial. And you can use that meeting to plan out, maybe the next week of work. Well, these group members are going to work on this, these group members are going to work on this. That's all really good stuff. And honestly, it's probably gets told to you every single group project you've ever done, but you really should do that as often as possible to keep in touch and so you know what everyone's working on. As we saw, there was sort of a nice progression through the different techniques, and naturally cell segmentation is something you have to get working first before you can really see success out of your tracking methods and your analysis. Obviously, you can have code written ready to do that, but those won't be giving you good results until you get cell segmentation working. So that feels like a natural first section to focus on when you're finding techniques and starting some implementations. Oh yeah, thank you for that. Yeah, that's the library link. That's good. Okay. Yeah, and something that works for a lot of groups, because 5 is quite a big number. You can have your group split up to experiment with different approaches. Maybe you've done your literature review, you're not sure we're going to use this technique or this one. You can split up and try both of them and see what works. So use the fact that you have 5 group members. You could try 5 different things. If everyone's contributing, that would be fantastic. As well, so this session is obviously a group one with everyone together, but we're going to split up in a second and you can ask questions. But from next week onwards, it will be split up and each group will have approximately like a 15-minute time slot within this 7 to 8 o'clock window, where it'll be just your group of 4 or 5 people with one tutor. And that'll be your time to ask questions, update your tutor on what you're working on, show some progress, things like that. So to get the most out of that time, we encourage you to have some code, some initial results, or some research that you've done ready to show your tutor. If you've got any questions, write those down. Make sure that you're not forgetting to ask them. So, I guess the advice there is just make sure you come prepared to those sessions from next week onwards, and you'll get the most value out of them. Okay, so that's pretty much it for the presentation. And yeah, Anthony, I'll send those out after this session. So we've got about 20 minutes left for questions. Let me stop sharing my screen.
Also, just adding on that, so the sessions, we're not going to be using this Blackboard Collaborate and then like have everyone split into breakout rooms, because everyone will have like their set time. Odds are there could be like Microsoft Teams channels created for each group, and then we'll contact you through then. That's kind of still to be determined, but hopefully by this weekend or early next week, we'll know from the admins and can have that Teams channel created for each group, or if there's some other plan, we'll reach out to you guys via email.
Yeah, exactly. So it's not on you guys to reach out to us to organize that. It's on us. So yeah, you'll get some sort of notification. You'll be added to something, or you'll receive an email, and through that, we'll organize those sessions. Yeah, good point. So there's nothing you guys have to do. That'll be set up for you, and yeah, hopefully at the latest, like sort of Monday, Tuesday next week. So we've got time to organize schedules and everything. Okay, sweet, awesome. If no one has any other questions for like the group as a whole, I suppose Andrew and I will hop into the help rooms. There might be some people here who weren't in the lab sessions, because we've got quite a few people here. At this point, if you don't have any questions, or you don't want to have a chat with other students or work with your group or anything like that, you're free to go, and we'll email those slides to you so you have them as a reference for later. Otherwise, if you do have a question, if you scroll down in the on the right-hand side in the Collaborate panel, you'll see 2 help rooms, and Andrew and I will be in each of those, and you can hop in and ask a question without everyone else seeing it. So hopefully that's a good environment to get your questions answered. Okay, yeah, so if you have a question, hop on in. I'll move to the help room now, and yeah, hopefully talk to someone soon. Sweet.
Thanks, guys.